3D printing refers to a variety of processes in which layers of materials, typically plastic, are deposited and joined one on top of the other in order to form a three-dimensional object. This process begins with a digital 3D model that is then converted into an STL file, where the 3D printer's software then slices this model into thin two-dimensional layers, turning them into a set of instructions known as a G-code. The next step varies depending on whether you are using plastic or metal, where typically FDM printers deal with plastics and large industrial SLS printers deal with metals. FDM printers work by using a nozzle to melt down these plastics instantly and precisely layering them above one another, working from the bottom up. SLS printers, on the other hand, use a laser to melt thin layers of metal to achieve the desired print. These prints typically take anywhere from 4 to 18 hours to complete, depending on the size and sophistication of the print. However, once they are completed, they often require some post-processing in order to achieve the desired finished look of the product. As the classroom continues to evolve, both manufacturers and educators are leveraging the benefits of 3D printers in schools. 3D printers are extremely beneficial in assisting and augmenting the way kids today learn, as they possess the capability to bring almost any education concept to life. Although 3D printers can be expensive and difficult to afford for most school budgets, costs continue to drop and resources and grants have become increasingly available for K-12 institutions that want to revamp their program. By learning more about the ways in which 3D printing can be used to foster engagement, deeper learning, and the strengthening of workforce skills, teachers, schools, and districts will be able to see the benefits of bringing 3D printing into the classroom and, in effect, assisting their students at becoming better off and more informed citizens of tomorrow. 3D printing seems to be improving every year as they find new roles in the world of manufacturing. Many aspects of this technology have become mainstream and have been adopted by both hobbyists and professionals alike. However, these advancements in 3D printing have been particularly beneficial in the aerospace and defense industry. Being one of the earliest adopters, the aerospace and defense industry now represents a 16.8% share of the $10.4 billion 3D printing market, as they continue to contribute to ongoing research and development efforts. The quickness and precision of 3D printing has allowed for the creation of functional prototypes where designers can gain insight on the dimensions of aircrafts or components and how they perform. However, 3D printing in aerospace and defense isn't limited to just prototyping. They also create real functional parts that are being used in the aircraft themselves, including air ducts, wall panels, and even structural metal components. For an industry such as aerospace and defense that is so reliant on highly complex parts being produced in low volumes, 3D printing is particularly beneficial. This technology has almost no limitations on what forms it can create, as it consistently generates complex geometries without the need for investment in expensive tooling equipment, which offers aerospace companies and their suppliers an extremely cost-effective way of producing small batches of parts. Another benefit comes from the aerodynamics and performance of these aircrafts, where weight is also an important variable. 3D technology is ideal in this aspect as they can be coupled with design optimization tools that enable the potential for considerable fuel savings. Automobile manufacturers have also been finding ways to incorporate 3D printing into their operations as they aim to improve their daily operations. Therefore, finding creative ways to use 3D printing in this industry has become increasingly important to ensure that they stay ahead of the competition and don't get left behind. One such company that could benefit from the use of 3D printing is Alfa Romeo, an Italian car manufacturer. Alfa Romeo has long stood for exotic performance cars that are in a price range comparable to that of BMW or Mercedes. However, Alfa Romeo has been slipping in their market share as larger competitors are edging them out. In order to regain some footing, Alfa Romeo could incorporate 3D printing in order to add customization and complexity to their already unique looking cars in order to further differentiate themselves and add a sort of prestige. This would allow them to occupy a new market to which their current price range would allow them to cater to a much larger market share of individuals looking for the performance and prestige of an exotic Italian badge without the costliness associated with customized luxury add-ons. 3D printing is currently a pretty expensive technology that is out of the price range of most of us, limiting its uses to most large corporations or individuals that are more well off. But as we become increasingly educated on the way 3D printing works, the wide variety of applications in which we use it is rising significantly. From manufacturing and engineering to construction and medicine, the world is becoming increasingly aware of the wonders that this technology can provide us with. However, most of these applications have been to either assist the function of a product or used to gain insight of the functionality of a product. When will we see the mass production of end-use applications? I believe that this won't actually be too far in the future. The rate at which 3D printing has evolved in the past 2 decades could enable some companies to benefit tremendously by replacing their current operations with a range of 3D printers that would automate the entire process at a fraction of the cost. This reality, however, would be limited more so to companies that already have a relatively simple product. But as 3D printing continues to evolve at its current rate, we could possibly be living in 3D printed homes or driving to work in our 3D printed cars in the coming decades. Liberia currently ranks 112th out of 117 countries on the 2019 Global Hunger Index, with approximately 45% of their population being chronically or acutely malnourished. The country continues to struggle with several internal and external conflicts that lead to a plummeting economic situation. As their economy worsens, the prices of products has increased as incomes have decreased, making it increasingly difficult for families to sustain their basic needs. However, I believe that 3D printing would be extremely effective at addressing these needs. The small remote villages in Liberia would be able to cheaply print a wide range of tools and products that could be used to ease the burden of their crippling economy. These Liberians would be able to print such tools like buckets to carry water or shovels and plows, which would allow them to meet food shortages by increasing their own output of agriculture and farming. This wouldn't be a long-term solution, but would allow for the people of Liberia to concentrate less of their energy on surviving and putting a larger emphasis on improving their economy.